Okay, so first thing we're going to do is we're going to go through the 2.1 through 2.3 check. If it's on here, do you think it's going to be on your quiz on Thursday? Yes, okay? It's this stuff plus the lesson we're going to do today. Okay, so if this was really easy for you, the quiz should be fairly easy for you. So the first thing at the top, the vocabulary, and this is something you will have to know for the quiz. Okay, you have to know these words. And some of you guys did pretty well. You just got a few of them, you got them mixed up. So, number 1, what do we call the little number that's kind of hanging out up in the air? Sadie? The exponent. Okay, so number 1, the little number is called the exponent. What is the big number called, Brady?
The base.
The base. Good job. And again, fix these if you missed them, if I didn't already fix them for you. And then when we have a base with an exponent, when it's all put together, what do we call it, Max?
Power.
A power. Good job. Okay, so if it's just a little number, it's an exponent. The big number, the base. But you have to have a base with an exponent. And when we have it all together, when we have a base number and an exponent, we call it a power. The second part says write each product as a power. First, what is a power? What is a power, Finley? A base number with an exponent. Did it ask for the value? No. If on the quiz you give me the value, you will lose points because you're not answering the question that it's asking for. Okay? So Finley, what is 8 times 8 times 8 as a power?
8 cubed.
She said 8 cubed. Who can say that number a different way? Parker?
8 to the 3rd power.
Good job. 8 to the 3rd power. Number 2, Brody, how do I say 9 times 9 times 9 as a power?
9 cubed.
9 cubed? Or Sadie, how else could I say it? 9 to the 3rd power. Good job. Next one, it says write each power as a product of the same factor. Jude, what does the word product mean?
Like power or value.
Nope. Well, what is a product? I think, Kendall?
It's like the value of a multiplication.
So it is the answer to a multiplication problem. But this means we're writing a multiplication problem with the same factor. Okay, so when it says it wants a product of the same factor, does it want the value of the power?
No.
No. What does it want here, Nate?
Like you write the 2 8 times.
Yeah, I write 2 8 times. 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7, 8. If it wants me to find the value, it'll say find the value or evaluate the expression. But that's all you had to do on that one. Is the value of that 16? What did I do to get 16, Brant? 2 to the 8th.
You did
2 times 8, is that how we do exponents? No, they take us a little bit longer. We have to take 2 times 2 and get 4. 4 times 2 is 8 and build it up from there. Next one, number 4. Abby, what should I write?
5 times 5
Okay,
times 5 times 5.
good job. 5 times 5 times 5 times 5. Now, last one. Find the prime factorization of 32. Right answer using exponents. Some of you forgot that part. So this one, here's how I came up with the 9 points for the assignment, okay? I did 1, 2, 3, 4, 5, 6, 7. If you got the prime factorization correct, you got a point. And then writing it as an exponent. was the 9th point. So that's where the 9 points came from on this. So if you factored it correctly, then you got 1 point for finding the prime factorization, and you just lost the point for not writing it as an exponent. Okay, so I'm going to do mine out here to the side. 32. Who can help me get started? Go ahead, Kendall.
4 times 8.
4 times 8. If you missed this one, I want you to fix it. 4 times 8. Finley, am I done yet?
No.
Why not?
Because 4 and 8 can be divided.
Yeah, because the 4 and 8 are not prime numbers. Remember, I am done when my whole bottom row is prime. Harper, break one of those down for me.
4 goes into 2 and 2.
Okay, 4 can be broken down into 2 times 2. Do the other one for me, Bryce.
8 can be broken down into 4 times 2.
Okay, can be broken down into 4 times 2. And I had lots of people stop there. Okay? And they broke down this 4, but then they left that one down there. Okay? Sadie, tell me why I'm not done yet.
Because the 4 can be broken down again.
Yeah, because 4 is not a prime number. We cannot be done until we're all prime. So we drop the 2, drop the 2. This 4 gets broken into 2 times 2. And drop that 2 down. So if you got that far, you got 1 point. Reese, how do I write 2 times 2 times 2 times 2 times 2 as using an exponent?
2 to the 5th power.
Good job. 2 to the 5th power. Questions on the quick check? Again, if that was easy for you, that's very, very similar to your quiz. Okay? Again, the hardest part is knowing how to give your answer. So your notes paper that we did on loose leaf, where we turned it sideways, the 6 possible questions that it could ask are at the top. Okay, if it asks for the product as a power is a base number with an exponent. If it asked for it using exponents, you need a base and an exponent. If it wants you to write it like this, right there in the middle, like these ones, 8 times 8 times 8, or 9 times 9 times 9. What are some questions it could ask if it wants it like one of those? Kendall?
Write the product as the same power.
As a product of the same factor. So remember, the factors are the pieces in the math problem. Or it could say write it as an expression. No questions on this? Okay, pull out the notes page that you grabbed off the Chromebook cart. Give me just a second to get it pulled up. I want you to kind of look through it. I want you to kind of look through what we're learning today. Go ahead and put your name at the top. Okay, Haley, why do you think you're going to like it?
Because I think like it looks easy because it's just you multiply the first 2 numbers and then add on the 0.
Yeah, it's kind of like the mental math that we've already discussed quite a bit that's been on our weekly worksheets. Look for something that looks new. Well, we're waiting on yet.
Multiplying by powers of 10.
Okay, multiplying by powers of 10 is the new. That last little section at the bottom. My goodness, my board's not doing anything. Apparently my board had a long weekend. It's not quite awake this morning. There we go. I think it's finally awake. Let's cross our fingers. I just need one more click and we got it. Okay, since you guys are already familiar with the first ones, who can tell me how to do 4 times 50, or the thought process that I need to go through. Make this a little bit bigger. Who can tell me what I need to think about? Dane, go ahead. Tell me what I need to do.
4 times 5 and then put a 0 on it.
Yeah, so I want you to underline 4 times 5. Good job, Dane. 4 times 5. We're going to break these into easier problems. Dane, what is 4 times 5? 20. And then, however many zeros are in my problem, I need to add them to my answer. So there's only 1 0 here, so I need to add 1 0 to my answer. Why are there 2 zeros in my answer and there was only 1 0 in my problem, Bryce?
Because when you multiplied 4 times 5, it was a 2-digit number and it had a 0.
Yeah, because my mental math problem ended in a 0. So the number of zeros in the problem do not always match the number of zeros in my answer. And the only time it's different is if my mental math problem ends in a 0 also, because that'll add an extra 0 in our answer. Next one, Brody, walk me through what I need to think about. What's my mental math problem in the second one? When you look at it, what 2 numbers are you like, hey, I can multiply those 2 numbers together? Yeah, 6 and 3. So we're going to underline 6 and 3 because that's our mental math problem. Caden, what is 6 times 3?
6 times 3 equals 18.
Is 18. Good job. Is my answer 18? No. Maya, what do I do next? Okay, why do I add 2 zeros? Yeah, there's 1, 2 zeros in my problem, so I need to add 2 zeros in my answer. What else do I need to add to my answer, Brant? A comma. I don't suggest you add the commas till you're completely done with the problem. Next one, Reese, help me out. What am I going to underline?
6 and 4.
Okay, what is 6 times 4, Reese? 24. Finley, how many zeros do I add behind that? What'd you say?
3.
I think you were right the first time. What'd you say? But we count all the zeros in the problem. So 1, 2, 3, 4 zeros in my problem. So I need to add 1, 2, 3, 4 zeros to my answer. And then I start at the back, count 3, put in my comma. Finley, do you have a pencil to use? Next one. Abby, help me out. What's my mental math problem? 9 times 2. Good job. Do you know what 9 times 2 is, Abby? 18. Jude, how many zeros do I need to add to that 18?
4.
Why?
There's 4 in
There's 4 in the problem. 1, 2, 3, 4. So I have to add 4 to my answer. Lori, next one. What's my mental math problem?
1 times 5.
1 times 5 is what?
5.
5. Maya, how many zeros do I need to add to that answer? Okay, 6 because there's 1, 2, 3, 4, 5, 6 in my problem. So I need 1, 2, 3, 4, 5, 6 in my answer. Go in and add my commas. Haley, why is this one different?
Because it's 2 digits times 1 digit.
Okay, and why should we all be able to count by 25s? What do you really like, Reese?
Money.
You like money, and what money can you connect to 25?
Quarters.
Quarters. So, Haley, if you have 2 quarters, how many cents do you have?
50 cents.
50. So 25 times 2 is 50. How many zeros do I need to add to that, Kendall? 2. So 1, 2. So I add 1, 2. Why are there only 2 zeros in my problem but 3 zeros in my answer, Brant?
Because 25 times 2 is 50.
Yeah, because my mental math problem ended in a 0. Those are the ones you guys will miss because you'll just pay attention to the zeros. So a lot of times I will see where people will have an extra one and then erase it because they go back and count the problem and there were only 2. So they only put 2 in their answer, okay? So just slow down on those ones where your mental math problem ends in a 0. Raise your hand if you're really liking this section right now, okay? Now, it really doesn't get much harder, but we have to connect what we're doing there with what we know about exponents, okay? So in the next one, we're talking all about powers of 10. The older you get, powers of 10 are the most common types of exponents that you will work with. 10 squared, 10 cubed, 10 to the 4th, 10 to the 5th. In the upper grade science classes, you will write in scientific notation, which is using powers of 10. Because usually in science, things are very, very large or very, very small, like to measure from here to the moon. That's a number with a lot of zeros behind it. So instead, they write it in scientific notation to shorten up that number. So they use exponents to write it in an easier way. Now, erase that to go on up. So the next one, we're just finding the value of each power. If I am finding the value, Nate, what am I doing if I'm finding a value of an exponent? Yeah, I'm doing the multiplication and I'm getting a value for it. I'm evaluating it. So, and this table's a little bit confusing, but if you follow all the words and the arrows, 10 to the 3rd power, or how else could I say that? 10 cubed, good job. It says write it as a product of the same factor. So who thinks they know what I need right here? If I'm writing it as a product of the same factor. Sadie?
10 times 10 times 10.
Yep, so 10 times 10 times 10. Now, our mental math strategy works for this too. Just don't outsmart yourself. What is my mental math problem here? Lori?
1 times 1 times.
Yeah, 1 times 1 times 1. See if anybody makes the common error. Brant, what's 1 times 1 times 1? Yeah, 1. Raise your hand if you were thinking 3. Go ahead. I see Brant corrected himself. Common wrong answer here is 3,000. Because you're thinking 1 times 1 times 1, there's 3 ones, that's 3. But 1 times itself, no matter how many times, is always 1. So this is 1 times 1 times 1 is 1. How many zeros do I need behind it, Brant? 3. So the value of 10 cubed is 1,000. Let's go down from there. 10 to the 7th. Dom, how can I write that out as a product of the same factor? Yeah, 7 tens. Good job. 3, 4, 5, 6, 7. Let me double check. 1, 2, 3, 4, 5, 6, 7. Okay, 10 times 10 times 10 times 10 times 10 times 10 times 10. Dane, what's my mental math that I have to do to find the value of 10 to the 7th?
10 times 10.
Make it easier on you.
1 times 1 times 1 times 1 times 1.
Yeah, 1 times 1 times 1 times 1, 7 times. What is 1 times 1 times 1 times 1, 7 times, Dane? 1. Common wrong answer is 7. But it is 1. Then how many zeros are in my problem, Jude? 7. So how many do I need in my answer? 7. 1, 2, 3, 4, 5, 6, 7. Backwards. Next one, notice it's not asking me to write it as a product of the same factor. This one I want you to write value on this line. Somehow that got chopped off. Does yours say value on that line or is it blank? Okay, so write value on that bottom center row of your table. Right there. Who remembers 10 to the 0? That means we have no 10s in our problem. Brady, what is the value of anything to the 0 power? Nope.
1.
Haley?
1.
1. Any number to the 0 power is 1. Okay, common wrong answer is 0, but let me show you why it's 1. Okay, I'm going to do 7 squared times 10 to the 0. What is 7 squared? Lori? 49. So this is really 49 times whatever 10 to the 0 is. If the value of 10 to the 0 is 0, what does it do to your whole problem? Yeah, it kind of wipes out your entire problem. And it's not that there's not 7s. We have 2 7s and we have 0 10s. So anything to the 0 power is just 1, because it's not getting rid of the other stuff that's there. It's just saying there are 0 10s in this answer. Okay, and you don't have to know why. It sometimes helps you guys remember what the value of anything to the 0 is. What about over on 10 to, let's go to the top. 10 to the 5th. Bryson, how do I write that as a product of the same factor?
10 times 10 times 10 times 10.
Good job. 10 times itself 5 times. Sophie, what is my mental math?
1 times 1 times 1 times 1 times.
Good job. 1 times 1 times 1 times 1 times 1 is 1. Parker, how many zeros do I need in my answer?
5.
Why?
Because there are 5 10s.
Good job. Well, because there's 5 zeros in my problem. Good job. Go and put in our commas. 10 to the 4th, Max. How do I write that as a product of the same factor?
10 times 10 times 10 times 10.
Good job. 10 times 10 times 10 times 10. Okay, Lori?
1 times 1 times 1 times 1 equals 1.
Okay, 1 times 1 times 1 times 1 equals 1. Keep going.
And you add 4 zeros.
I add 4 zeros. Why do I add 4 zeros, Lori?
Because there are 4 zeros in the expression.
Because there are 4 zeros in the expression. Good job. Kendall, last one. What is the value of 10 to the 1st power? It's just saying I have 1 10. It's just 10. Good job. Those bottom 2 are the ones that get you sometimes. I call those ones, they're so easy, they're hard. You try and you think it should be harder than what it is. Questions on those ones? Now, before I clear that, underneath it, it says, what do you notice? So let's look at our powers, look at our answers. What do you notice about 10 cubed and its value? About 10 to the 7th and its value? 10 to the 5th and its value, and 10 to the 4th and its value? Dane, what do you notice?
I noticed that everything starts with 1.
Okay, everything starts with a 1. I agree. The value of all powers of 10 have a 1 as their first digit. Okay? Let's go ahead and write that. That's something we can notice. Let's put a bullet point. All powers of 10 have a value that starts with a 1. I'm going to abbreviate with. Have you guys seen that abbreviation before? A W with a slash behind it is the abbreviation for with. So all powers of 10 have a value that starts with 1. Is he correct on that? Yep. Even 10 to the 0 starts with a 1. Kendall, what else do you notice?
All of them are 10, like they're all 10s.
When we write them as a product, yep, you are correct. But we're not going to write that one. She said that they're all 10s when we write it as a product of the same factor. She's right, but we're wanting to see, what do we notice about this compared to that? The power compared to the value. There's something else I want you to notice. Anybody else notice anything? Brady?
The exponent is how much, like the number, the exponent, like 10 to the 7th power, the
would mean that there would be like 7 zeros in.
Yeah, he noticed that the exponent is the same as the number of zeros in the value. So here the exponent was 3, and there were 3 zeros in the value. And we already said the first number is always going to be a what? A 1. So if we can remember that the first number is always a 1, and the exponent tells us the number of zeros, that can speed it up. But that's a trick. If you can't remember the trick, how long did it take us to write out 10 times 10 times 10 and find the value? Did it take very long? No. Yeah, it doesn't take long at all. So you can either write it out, 10 times 10 times 10, and then think through. 1 times 1 is 1. And then count up your zeros. But there is a trick, and it is that the number of exponents tells you how many zeros are in the value. But that only works for powers of 10. Everybody repeat that. It only works for powers of 10. Okay, so if you see 4 to the 5th, it's not a 4 with 5 zeros behind it. Okay, that only works for powers of 10. So I'm going to go up a little bit, and we're going to write in the other thing we noticed. So I want you to write in, on the second line, the exponent tells how many zeros are in the value. The exponent tells how many zeros are in the value. And again, that's a trick. But if you can't remember it, just write it out as a multiplication problem and do the mental math. Now, the problems at the bottom are two-step problems, which means you won't get the answer in one step. Okay? We're going to start talking about the order of operations, which I believe you talked about last year, right? Mm-hmm. What is a saying? Were you guys taught a saying to help you remember the order of operations, Haley?
Please excuse my dear Aunt Sally.
Yeah, please excuse my dear Aunt Sally, okay? Or PEMDAS is what some people say. What does the P stand for? Who remembers what the P stands for? Sadie? Parentheses, which means anything in parentheses, you do that first. Okay, the way I've always remembered it is I went to school with a boy who was deaf, and he had a teacher's aide who was in class with him, and she would stand up and sign to him all class, and she'd do this a lot to him, which when I put my hands around my face like that, what does it look like? It looks like parentheses. Do you know what this means in sign language? Anybody know? It means focus, and she'd do that to him all day long, like focus. So parentheses mean like put your focus right here. And I don't know if that's where they came up with that sign, but that's how I've always remembered, is that she was always telling him to focus. So parentheses kind of look like that, and it means, hey, focus your attention right here. If there's parentheses, it's saying look right here. So parentheses come first, which we're not there yet. We don't have any parentheses. What does the E stand for, Maya? Exponents. Do these problems have exponents? Yeah. My dear. I always say together because they go together. Reese, what does my dear stand for?
Multiplying and dividing.
Does anybody know the rest of the rule? It is multiply and divide, but there's a little bit more that we're going to have to remember. Dane? That's not yet. Something with multiply and divide. Maya? Same thing. Harper? From left to right. That's important because it's not always multiply and then divide. It's multiply and divide from left to right. So if there's multiplication and division, you always start on the left and work your way across. Same thing with add and subtract. Okay? So because of the order of operations, when we get to these next problems, it has two operations in it. It has multiplication and it has exponents. If we follow the order of operations, which we must follow in order to get the right answer, we have to do our exponents first. So I want you to underline 10 cubed. Because we have to figure out the value of 10 cubed before we can go on. Now, you have options. We can write down 10 times 10 times 10. I want us to do that the first time. 10 times 10 times 10. Brody, how can I figure out the value of 10 times 10 times 10? What mental math problem can I do?
10 times 3.
Nope, what's 1 times 1 times 1? 1, and then how many zeros do I need behind that, Brody?
1.
There's 1, 2, 3 in my problem, so I need 3 in my answer. So I just found the value of 1,000, and that's the longest way possible. But did it take us very long? No, so if you need to do that to get the right answer. Abby, am I done with the problem?
No.
Why not?
Because you still have the 4.
Yeah, I haven't done anything with the 4. So first I'm just going to drop it down. Now I have a mental math problem like I had at the top of the paper. Parker, what's 4 times 1,000? Yeah, because it's 4 times 1, and then add our 3 zeros. Let's circle it because that's our final answer. Okay, so that's option 1. Write out your 10 times 10 times 10 however many times you need to. Option 2 is remember our trick. So 10 to the 4th, I'm still going to underline it because I'm showing, hey, here's the problem I'm doing first. Kendall, what is my trick?
The 4 doesn't include other zeros.
Okay, she says the exponent of 4 tells me there's going to be 4 zeros. What always goes in front of my zeros? A 1. So I know a power of 10. The value always starts with a 1. And the exponent tells me how many zeros. So then I'm going to copy down my 6 times. Now we have mental math. Abby, what's 6 times 1? 6. How many zeros do I need behind that answer? 4. 1, 2, 3, 4. Fill in my comma. Dom, on the next one. What is the value of 10 squared? Okay, so 10 squared is 10 times 10. What's 10 times 10? 100. Okay, so I have 100. I have to drop down my 80 times. Nate, what is my mental math problem here?
80 times 1.
Just do the without the zeros.
8 times 1.
8 times 1. What is 8 times 1, Nate? 8. And then how many zeros do I need to add to my answer?
3.
Why?
3.
Yep, I have to add 3 because there's 1, 2, 3 in my problem. Next one, Lori, where do I start?
1 times 1 times 1 is 4.
Okay, so the value of 10 to the 4th, okay, and you're writing it out?
And then it has 4 zeros.
Okay, so 1 times 1 times 1 is 1, and you said it has 4 zeros. Okay. Now what?
Then you bring down 700.
Yep, I have to drop that 700. I can't forget about it. Brant, take over. Now what?
7 times 1.
Good job. 7 times 1 is what? 7.
6, and then there's 6 zeros in your
Yep, there are 6 problems in my, or zeros in my problem. 1, 2, 3, 4, 5, 6. So I have 6 in my answer. And then I add in my commas. Next one, Parker. What is 10 to the 0 power? 1. Is my whole answer 1? What do I do next? Yeah, I have to drop down my 30. And Reese, what is 30 times 1? 30. Next one. Bryce, help me out. 10 to the third power is, what is its value? 1,000. What did you do in your head to come up with that?
I did 10 times 10, which is 100 times 10.
Okay, so you did the 10 times 10 times 10. Raise your hand if you just knew it started with a 1 and you added 3 zeros because the exponent was 3. Are those both okay? Yes. I'm going to fill in my 1,000. I'm going to drop my 600. Finley, help me finish this one. What's my mental math? Look up here. What numbers can I mentally multiply together? Okay, what's 6 times 1, Finley? 6, and then how many zeros do I need behind that? 5. Why? Because there's 5 zeros in my problem. Okay, these are the ones that you're going to have to slow down on a little bit, okay? But it's not that they're super, super difficult. It's that there's lots of goofy mistakes that you can make, okay? Make sure you double count your zeros in your answer, because a lot of times people like circle the exponent saying there should be 5 zeros, but then they'll write in 6, okay, because they're going too quickly. So your homework tonight is a worksheet that looks very, very similar to your notes. I'm going to show you it up here first. Okay, there's a mental math section. There's a power of 10, and it looks very similar to your notes page. Then I will tell you on the worksheet, see how it says more on back? That printed on the back instead of on the bottom of the front. But I'm telling you, there is a back to your worksheet, and it looks like this. It's multiplying by powers of 10. Okay? And the worksheet is up on the table, so you guys may grab one and go ahead and get started. We have about 10 minutes of math time left.